Okay, we've got another question that kicks off with the R alpha method. Okay, now the shortcuts tell me that when I come to work out R, I'm going to be doing R. We know that R will turn out to be the square root of 3 squared plus 2 squared, which is going to be the square root of 13. And we know that tan alpha, when we get there, is going to end up being either 3 over 2 or 2 over 3. It's kind enough to tell me that alpha is acute, so it's got a positive tangent. Okay, so I can definitely scoot straight to R, and tan alpha I could do a bit of trial and error and I might get some marks. Okay, however, doing it properly, we start with the target expression, R sine of x plus alpha, which we expand out. So sine of a plus b is sine a cos b plus cos a sine b. So it's sine x cos alpha, and it's going to be cos x sine alpha, but they're both being multiplied by R. This one has a plus in the middle, and it's that's got to equal the 3 sine x plus 2 cos x. Now I'm going to do a little bit of colouring. So my sine x in red, here's my sine x term over here. So what have I got matching together with the sine x? It's going to be something equals 3. And what have I got with the sine x here? It's r cos alpha. So r cos alpha equals 3. Sometimes you get r cos alpha first, sometimes you get r sine alpha first. And the other one is going to be, well, change colour actually. Let's not have red, let's have green. So with cos x, where's my cos x over here? Here it is. Okay, here with my cos x, what goes with the cos x is r sine alpha. And what goes with the cos x here is 2. So these two statements, okay, are the really convincing bit that I've done it properly. Okay, right. Now, this method for R comes from, if you remember, it's the fact that sine squared alpha plus cos squared alpha equals 1. But I'm perfectly happy for you to go straight to the Pythagoras method for R using these numbers of 3 and the 2. But for the tan alpha, now I know which one is r sine alpha and which one is r cos alpha, I can get my tan alpha the right way up. Okay, it's going to be r sine alpha over the r cos alpha. So the r's would cancel and I'd end up with tan alpha. But if the r's are in there, I know that r sine alpha is 2 and r cos alpha is 3. So tan alpha is 2/3. So alpha equals, well, they're kind. They tell me that it's an acute angle. So although there are 2 solutions for tan alpha equaling 2/3, I know I want the acute one, so I can do inverse tan of 2/3 on my calculator. We're in radians, and my calculator is telling me that 0.588 to 3 significant figures. Okay, have I finished? Just about, but I should actually say what I found. So 3 sine of x plus 2 cos of x equals r, which is root 13, times sine of brackets x plus 0.588 radians. Okay, and that is my answer. Okay, all right, part 2. Write down the maximum and minimum values of this expression. Sometimes they ask you for transformations, or they might just ask you for a maximum or minimum values. Okay, so I mean, using transformations, we could say that this plus 0.588 inside is going to shift my sine graph sideways, but it's not going to move it up or down or stretch it. So this is not going to affect the maximum and minimum values. But multiplying by root 13 outside is going to cause a stretch like this and make it root 13 times bigger, and that is going to affect the maximum and minimum values. Or we can just think about sine of bracket and what its maximum and minimum values are. So sine of the bracket, well, the maximum value that sine of anything can be is 1, and the minimum is -1. So therefore, if I do root 13 times sine of the bracket, the maximum value of that is going to be root 13, and its minimum is going to be minus root 13. Okay, so that is my answer to dotty 2. The maximum value equals root 13, and the minimum value is minus root 13. Okay. Finally, we've got to get the value of x in between 0 and 2 pi, for which the maximum occurs. Okay, right, so how do I get the maximum? How did I get this root 13? Well, it's when sine of the bracket equals 1. Okay, the bracket I'm now going to fill in. I didn't need to for the last bit, but the bracket was x plus 0.588. Well, I know that I need sine of the bracket to equal 1. So this will occur when, well, what angle do I need to be doing sine of to get, so what needs to be in the bracket to get an answer of 1? What angle, when I do sine of it, do I get an answer of 1? Well, the sine graph looks like this. Okay, here's the answer of 1. What angle is it that gives me an answer of 1? Well, the answer is, it is 90 degrees, but we're in radians, so it's pi by 2. So therefore, to get this answer, sine of bracket equaling 1, I mean, I could solve that as an equation. I could set up sine of, I could say that root 13 sine of bracket, once I know that the maximum value I'm after is root 13, that's the equation I'm solving. So what we're saying is that in order for root 13 sine of bracket to equal its maximum value of root 13, sine of bracket x plus 0.588, that's a point in there, 0.588 must equal 1. Okay, so therefore x plus 0.588, well, you could even do the inverse sine of 1, but you're expected to know that's pi by 2 radians. So x equals 0.588 we said would have to be inverse sine of 1, which is pi by 2. And so therefore x is going to equal pi by 2 minus this 0.588. And my calculator will do that for me. Pi by 2 minus that other thing is 0.983 to 3 significant figures. And that is in, I've got to check that I've got the value in the correct range. That is in the range 0 to 2 pi. 2 pi is about 6. So this is comfortably within the range. So that will do for that particular question.